All right, today we are going deep. We're getting under the hood of one of the biggest technological races in human history, the hunt for artificial general intelligence. We're going to look at what's powering AI right now, what the theoretical blueprint for a true superintelligence looks like, and how one company, Tesla, is betting that the real path to a thinking machine isn't through the digital world, but through the physical one. Okay, let's get into it. You know, everything we're going to talk about really boils down to this one question. Is AI actually getting smarter in a way we understand, or are we just getting incredibly good at making it bigger and faster? That question? Well, it frames this entire conversation.
So, to even start to answer that, we have to look at the engine that's powering AI today. And while the headlines are filled with all sorts of wild, futuristic ideas, the reality of how we're making progress right now is built on a surprisingly simple idea, even if it's on a massive scale, just scaling the machine.
Look, when you hear AI on the news, it's really important to remember we're not talking about some single conscious brain. Not at all. What we have today is more like a toolkit, a collection of incredibly powerful but very specialized statistical models. You've heard of large language models for text, right? Well, there are similar things for images and code, and they are all just absolute masters at finding patterns in huge amounts of data.
What's kind of wild is that for a while now, progress in AI has been pretty predictable. It follows something called scaling laws. Basically, you can reliably make your AI better by pouring more resources into these three buckets. You make the model itself bigger, which is like giving it more neurons, you feed it way more high-quality data to learn from, and you just throw an insane amount of raw computing power at the problem. So far, bigger has definitely meant better.
Okay, so if that's where we are right now, how do we get from this to, well, the big one? Let's talk about the hypothetical blueprint for what might come next, the singularity. What would it actually take to build a true superintelligence?
The phrase you really got to focus on here is recursively improve itself. This isn't just about an AI that's smarter than us. This is about an AI that's smart enough to design an even smarter AI, which then designs an even smarter one after that. You get this explosive, runaway chain reaction of intelligence that we just can't predict.
But, and this is a huge but, you don't just get there by making things bigger. A real superintelligence would need to clear at least 5 massive hurdles. First, it needs general reasoning, the ability to think across different subjects, not just one. Then, it needs a persistent memory and a real model of how the world works. From there, it would have to be able to set its own goals, and then, crucially, have that ability to actually improve its own code. And finally, the big one, the one that keeps people up at night, making absolutely sure it stays aligned with what we humans want.
So this gets us to the heart of a huge debate in the field. How does AGI even happen? Is it going to be this smooth, predictable ramp-up, where we just keep doing what we're doing and things just get gradually smarter? Or will it be a series of sudden step changes where we hit some invisible size threshold and a model just wakes up with a brand new ability like reasoning that we never saw coming?
Okay, with that debate in mind, let's look at a fascinating real-world case study. While a lot of the big tech players are all in on that digital scaling race, Tesla is making a completely different bet. They're basically arguing that the key to real intelligence isn't going to be found in text and images online, but by forcing an AI to learn from the messy physics of the real world.
Yeah, this quote right here, it's their entire philosophy. Think of it as the difference between book smarts and street smarts. A kid doesn't learn about gravity by reading a physics book, they learn by falling down. And Tesla is betting that for an AI to get a real intuitive grasp of the world, it has to be embodied. It has to be grounded in that same physical reality we are.
And they've built their whole strategy on these 3 technical pillars. First, you've got this unbelievable fire hose of data, real-world video coming from millions of their cars driving around every day. In the middle, you need the horsepower to process it all, so they built their own custom supercomputer, Dojo, just for that messy video data. And finally, it all powers a single, unified system that connects what the car sees directly to how it acts.
And this slide really breaks down why they're doing that. The old way to build a self-driving car was this clunky step-by-step process. You had one system for seeing, another for figuring out where you are, another for predicting, and another for planning. Tesla is just collapsing all of that into one network. It's the difference between following a super complicated checklist versus just driving. It's like building muscle memory for a machine.
Now the end goal here, the holy grail for this whole approach, is something called a world model. This is the AI's own internal simulation of reality.
It's the ability to mentally rehearse, to ask, what would happen if I turn the wheel right now, and play out the most likely results before it actually does anything. This is the foundation for real planning and reasoning.
But let's be real. It doesn't matter if you're on Team Tesla with the embodied approach or Team Big Digital Brain. The road to AGI is not clear for anyone. Every single researcher in this field eventually smacks into the same fundamental roadblocks, the great unsolved problems of AI.
And trust me, these barriers are monumental. Take causal reasoning. An AI today can see that a rooster crows and then the sun rises, but it can't figure out the rooster doesn't cause the sunrise. That's a huge leap. Or what about learning efficiently? A kid sees a dog once or twice and gets it. An AI needs millions of pictures. Then you've got huge challenges like giving it a reliable long-term memory or the ability to teach itself new skills. And underneath all of this is the absolutely insane cost and energy and computing power. You can't just throw more data at these problems. We're talking about needing brand new scientific breakthroughs to solve them.
Which brings us right back to the ultimate question, doesn't it? Will the first true AGI be born from a mind that has only ever known data, text, and code inside a computer? Or will it emerge from a system that learned by moving, seeing, and bumping into the messy, unpredictable physics of our own world? That, right there, is the multi-trillion-dollar question that's going to define the future of technology.